All right, welcome back to our math practice. The skill required to be able to understand the concept for this session is to be able to square these type of numbers. But a little bit more than that. Not only are we going to be squaring these type of numbers, but we will be more analytical and analyze what's going on with our results. So in green, I have color coded this. The numbers that I highlight, I want you to think of them as X values, all right? I will be saying the answer out loud, and you try to do it and check my own answer, and those will represent in yellow Y values, all right? I won't be writing any of this down yet, but I will be using that color code, all right? So let's get started. When I highlight to the number, give you some thinking time, and hopefully that you can check my work. So for example, if I highlight this one, hopefully you are thinking negative 12 times negative 12 or negative 12 squared and think 144, all right? So let's start with this number right here, 169, and this number, 9, and this number, 25, and this number, 9, and this number, 81, and this number, 0, and this number, 4, and this number, 16, and this number, 81 over 16, and this number right here, 57. Hopefully you got those. I hope that wasn't a little faster. I mean, at this point we should be comfortable with them, but the main thing that I want to highlight here, like I said, I'm going to use green to highlight. There are three types of numbers out of these randomly chosen numbers. Some are more carefully chosen than others, but again, the variety is there. What type of three numbers are up here? There's three types of numbers, and this is the boundary to give you a hint from previous video. They are positive numbers. I'm going to rewrite it as POS, positive. Well, like I said, there's the boundary, which is 0. 0 separates positives from what type of numbers? The negative. So those are three types of possibilities. And the question is, when squaring those type of numbers, what kind of Y values do we get in return, or what kind of result in return? So when we square something like 2, positive 2, 14, square root of 57, 9 over 4, 7, or 5, what kind of Y values do we get in return, or what kind of answer do we get in return? It was positive. We've explored something like that before, so just move on a little bit quicker than that time. What is 0 squared? What type of number is 0 squared? It is boundary back in return. It is neither positive or negative. But the last question to think about is what happens when we square something like negative 9 or negative 12, negative 4, negative 3? What kind of Y values do we get? Well, negative 3 squared is 9. This one squared is 144. This one squared is 81. They're all positive. And that's the main thing to keep in mind. If we get okay up to this point, we're going to take this and try and visualize it on a graph. All right, so that's number 2. We're moving on to number 2. And let's try to put that on a graph. All right, I like to have you try and visualize what this looks like if you've never seen it before, rather than start plotting numbers, which I will probably plot some points anyway. So if you already are familiar with this shape, just bear with me, right? But what I want to talk about is, so that maybe it makes a little more sense, what does that tell us? If what type of Y values can we get in return? Only positive and 0. So we know that all negative Y values on this graph cannot be part of the graph. So I'm using red to say there can be no possible Y values down here, okay? Think of it in that way. There cannot be possibly part of our graph down here. We're just eliminating half of the X and Y plane immediately just by knowing that. And what I do want to also, another point that we do know is the lowest point. What is the lowest point in this case? It's going to be a 0, because if you square a positive X, you're going to get a positive Y value. And if you square a negative X, you're going to get a negative Y value. So at this point, take some time to think what that looks like. And when I ask my students to do this, the most popular answers that I see in their notebook, they have 2 straight lines like that, which if they even think that, I know that they're on the right track. I'm happy to see this in their notebook. And I don't tell them if it's right or wrong immediately. And the other type of answer that you are probably familiar, and usually it's because those students have seen it before, is this one. Those are the 2 main ones that I see often. And they do recognize that as a lowest point. Hopefully you can see that 0 squared is 0. Any positive number squared is going to give you a positive in return, and any negative x value squared is going to give you a positive y value in return. So that's the main idea. And yeah, the one that is correct, if you're not familiar with it, is this one right here. And this one does not have the two linear segments. This one does have curvature. I'm trying to do my best job of displaying that here. Let's clean that up a bit. But that's the main idea, keep in mind. All right, one more time. There it is with that curvature. So it's not two line segments, it's not two steeper line segments. There is curvature, and I will fix that. It's just, we're just visualizing it for the first time, all right? There is curvature associated with this graph, not two linear segments. That's a different graph, okay? All right, this is the graph of y equals something squared. So I know that I wrote it as y equals x squared, but I do want you to think y equals x squared or y equals something squared. There's the graph that we will be using from this point forward. And that's the nice thing. We know there's no negative y value. So moving on, I'm going to make this for sure clean. I'm going to clean it up and use a nicer scale. So like I said, I was going to plot some points, maybe not, maybe more than I want to anyway. But the main question that I get when I discuss this with my students is, why does it curve? How do you know that it curves? And I like to do this to tie it to something that probably most algebra students know up to this point, which is linear graphs, and related to something that we explore in calculus. So one of the main ideas in those two courses is that a linear graph has a slope that's the same. So I label some points on this x and y linear graph. And the question is, how do I get from this point here to the next one, and from this point here to the next one, and from this point here to the next one? And you can see that it's up something and over something. That's known as the slope. What's the slope of this one? Up the same amount and over the same amount, up the same amount, over the same amount. I don't think the scale on my last one was very good, so I'm going to redo it. Up something and over something, up something and over something. That looks a little bit better. But you get the idea. The slope of all these three little triangles may have the same slope. And we can also go from this point to this point, from this point to this point, and just draw one triangle. What if we did up this amount and that amount? And now I'm going to replicate that from here to here, all right? From this point to this point, and hopefully you can see that's the same triangle as the one before. And I probably should have used a different color like blue. Let's redo it in blue. So you can see that this triangle is the same as that triangle. All right. The main thing here is that for linear graphs, the slope remains the same. It doesn't change. So if this were two linear segments, then the slope would be the same. So that's why I'm going to plot some points. And look, I have a pretty good scale. And I will use yellow for our y equals something square graph. All right. So remember, still in yellow to plot some points. What I'm plotting is y values. And this is what I mean. When x equals 1, what's the y value for 1 squared? It's going to be a 1. As a matter of fact, we should start with the lowest value that we've seen before. When x is 0, what's 0 squared? It is 0. All right. Let's think of more points. When x is 2, what's 2 squared? It is 4. And hopefully you can see that that's not going to create a linear segment. Absolutely not. When x is 3, what's 3 squared? It is 9. So that y value of 9 right there. Hopefully you can see that that's not going to, if I were to connect these two, I would miss the other ones. If I were to connect these two together, then it would miss the lowest point. All right. And then just because I've already made the scale, let's do it. 4 squared is 16 right there. And guess what? I went all the way to 25. Look, I gave myself an indication where 25 is, and 5 squared is 25. So we're going to go here, and that way you can see a clear picture of why this is something that must curve. All right, I'm going to try and do my best job of connecting these in segments and visualize that curvature. All right, see how I can do it right there. Oh, that's not the right type of curvature, however, but hopefully you get the idea. Oh no, I don't like that very much. Try one last time, and that's about it. it curves like that. Something like that. At this point, I'm just going to put arrows to indicate. That was more difficult than I thought. But I'm going to smoothen it out right there. You see that? There we go. All this is one smooth curve, however. All right, visualize one smooth fluid curve. And I'm going to draw the slope triangle so you can see that the slope is changing. What's the slope from here to here? Up 1 and over 1. That's the slope of 1. And what is the slope when we go to the next point? Up 3 units and over 1. Slope of 3. You can see the slope is changing. And to get to 9, to get to this point, it was up some number of units and over 1. The number of units, 9 minus 4 is 5. So you can see that's a slope of 5. And I'll do one more just so you can see that the slope is changing. How is it changing? The slope is getting steeper every time, which explains the curvature. All right. Oh, I think I know why I did that incorrectly. It was supposed to go here, but there it is. So then let's fix that. I think I can fix that. There we go. Like this. Oh, there we go. Now it's really easy to see that curvature in that smooth fluid curve that I was referring to. All right. There it is. That had a slope of 16 minus 9 should be a 7. Slope of 7. So there it is. This is a linear graph with constant slope that is not changing. And this is the y equals something squared, which has a slope that is every increment of x is getting steeper and steeper, which explains the curvature. And the nice thing about me doing this to scale is that now I'm going to actually plot some points that are negative. When x is -1. When x is -1, we get a +1. When x is -2, we get a +4, which creates this nice type of symmetry. I'm just going to go to -3, and 9, because as you saw in the previous right side, that was hard for me to sketch anyway. And you can see that smooth curvature that would connect those points fluidly. Something like that. Hopefully that you can see this is symmetric to this arrow part here. And there it is. These are important features about this graph. Not just plotting points and say, oh yeah, remember this shape, well, which is something that we're going to do, but there should be a reason behind that. All right. Okay, so hopefully you're okay with your understanding of what we've done so far. We just are taking x values, squaring their quantity, their value, and then plotting their result of the square as a y value. All right. But at some point, if they give us more complex advanced expressions or equations to graph that involve this format, it's going to be something that is not fun to do, plotting all of these numbers individually. All right, so I would like to call this the parent function. All right, it will be the parent function, because every other graph that we will sketch involving something square will be some transformation of this, some resemblance of that, or parent graph. At this point, I'm going to call it the parent graph. Parent graph, you can call it the mother graph, father graph, whatever you want. But think of it as a parent function. All right, something that's going to be transform and resemble that main parent. All right, so here we go. What are 3 key features of that graph, that parent function, which I will call y equals something square? Y equals something square. And if you would like to also keep it in mind, y equals something square, that's great. I like to do that. Matter of fact, that notation can be a little confusing. So I'll write it on this side. Y equals something squared, all right? So what are 3 key features? They were up here. We highlighted them already. One of the main things is that we cannot have in any number squared that give you negative y values. So for that reason, we had a lowest point. We had a lowest point. So that's what I'm going to say. And this is not complete for now, but it is sufficient up to this point. It has a lowest point. That's not always true, but let's accept that for now. It has a lowest point because there's no negative y values associated with it. And that lowest point is 0. All right, 0 is neutral, is the boundary. So it created this pretty cool symmetry. It created this nice symmetry about this line. And that line is the y-axis, otherwise known as x equals 0. Be careful, that's not y equals 0. That's x equals 0. The x value is 0 here anywhere on this line. That's why it's called that. So it also creates symmetry. And the nice thing is that that symmetry passes through which point of the graph? Let's see that again. That dashed line of symmetry is not part of the graph, but where does it, this line's pink dashed line does not belong to part of the graph, but where does it intersect the graph? It is right there at the lowest point. So symmetry through lowest point. Through lowest point. That's very important. All right. And I'm going to create more space here. The last one is it has a lowest point, it has symmetry, and we also said that it has curvature. Unlike other graphs that we've seen up to this point, this one has curvature and symmetry as well as the lowest point, curvature. All right. And we will see that there's different type of curvature, which, like I said, this is not complete for now, but it's taking us to where we want to go. All right, 2 more graphs. I didn't finish it. All I'm going to do is clean up the one from above. Anytime I sketch the parent function, it's just going to be, and I was trying to do it slow. It's just going to be something that we're going to sketch quickly like this. Something like that, like the previous graph. Yeah, it has curvature. I always like to draw my line of symmetry in dash format, so I can see that. This distance right here is the same as that distance right there, and this distance right here to the graph is the same as this distance from the line to the graph. Hopefully you can see that. Those are the 3 key features of this graph. And we will think about these 3 things anytime we sketch any of these graphs. So let's see how that will go. When we see something like y equals x squared, what are we going to think? We're going to think, all right, y equals something squared. And we know that it cannot have any positive, when squaring any type of numbers, we cannot have negative y values, and it has a lowest point. What else do we know? We know that it has a lowest point and the line of symmetry passes through that point. We know that it has curvature. That's it. That's the thought process when doing these. I want you to think of lowest point, line of symmetry, and curvature. All right. And the last one for this practice would be to sketch this first transformation. Remember that that word was used before. So I want you to think y equals something squared. That is the same as the one we did previously. So the one we did previously, I should have used yellow. Let's do that. The one that we did previously would look something like this. So I'm drawing it in dash color and dash line because that's not the graph of what we're trying to transform next. My question is, how did this equation become this equation? Now there's a -1 in front of it, which technically means times -1. Whatever the something square is times -1. So think of it as the something squared happens first and then times -1. That's the way you should think about it. So if we know that something squared could only be positive, what's going to happen to every one of these yellow y values whenever we multiply by -1? They're going to become positive, from positive to negative. And actually, I'm going to use the green color now to indicate that that's the graph. Everything that was yellow before now becomes a green y value. That's the thought process that we should be going through. And what's 0 times a -1 is still 0. So that value remains the same. But this one is, there's 2, what I'm trying to show you here is that there's 2 types of curvature. All right, so I'm trying to show you curvature with this transformation. All right, so in green, we can say this one is curving. How is this graph curving? Is it curving upwards or is it curving downwards? Look at where the arrows are pointing. It is curving down. Curving down. And the yellow one, how is that one curving? The yellow one is curving in that the arrows are pointing upwards. All right, so let's write that in this color, curving up. There it is, curving upwards and curving downwards. There's pretty much all we need to understand up to this point. I'm sorry if I made it too long trying to explain the curvature, but as long as you remember those 3 facts, we will be fine for the next series of transforming graphs that look like y resembles the form y equals something squared. All right, and also hopefully you understand that there's curving upwards, there's curving downwards, and in the next video involving sketching graphs, we're gonna do it quickly and also save some time. All right, so that's it for this practice. I hope to see you in the next